Hello everyone. Today we're gonna continue with the triangle congruence by the SSS and side angle side. Let's first analyze this section. The two main concepts I need to discuss are SSS postulate and the side angle side postulate. You will see how they are related. And in our worksheet, number 1 through 9 will be about whether the figures are congruent, and if they are, we have to say they are congruent by side or side angle side, and sometimes it may not be. In that case, you have to say not possible. And finally, on number 10 through 13 is a triangle given the three vertices A, B, and C. And 14 through 15 is about proof. For those, I will describe them in other videos. So here we go. So here's the side postulate. So it says if the three sides of one triangle are congruent to the three sides of another triangle. So as you can see here, there's a 1 tick mark, 2 tick mark, and 3 tick marks. And then when you put the same tick marks on the second polygon, or in this case a triangle, that means that the GH, the segment length GH, is equal to the segment length PQ, or I should say they're congruent. So if three sides of each triangle happen to be congruent, then we know the triangle are congruent. And the same is true for the side angle side. It said that if two sides, so we have two sides, and here's one embedded angle. They call this included angle, and it's embedded between these two sides or sandwiched by the two sides. When you get this side angle side, and also the side angle side congruency by the second figure, then we can conclude that both triangles are congruent. So congruent means that it has the same size and same shape. So here's the problem number 1. The direction tells us to decide whether you can use a side or a side angle side postulate to prove the triangles are congruent. So your answer should be yes or no based on the congruency. If so, write the congruent statement and identify the postulate. So if they are, you say, oh, this is congruent by side angle side or side postulate. And we'll have a problem here that's not possible. So in other words, we can't completely trust the figure just because they look like it. So let's start with the first one. So here's the red fonts are our goal in essence, and the given in this problem is two congruent triangles, and here is number 1. So here we have a side, so let me annotate this. Here's a side, and then there's an embedded angle. And here's another side. Now, by reflexive property, the BD, because it's adjacent to each polygon, each triangle, so it's shared. The BD, the segment BD is congruent with segment BD by reflexive property. So in other words, triangle ABD and DBC are congruent. So ABD. Okay, I will first start with a yes to the first part of the problem. ABD, triangle ABD, is congruent with the triangle DBC by side angle side postulate. Let's take a look at number 5. So again, we have a reflexive property for both polygon that the segment AY is shared. So here is the same side, and you can see that the supplementary of the right angle in this line ZB will be also 90 degrees. So it sounds good, side angle. However, we're not explicitly given that the segment ZA is congruent with segment BA. Since it's not given, so just side and angle doesn't necessarily mean they are congruent. So let me exaggerate. What if I have figure like this? Okay? Because I'm not explicitly given that AZ is has same length with AB, what if I really have this? So in that case, it's not even similar, it's not congruent, so I will say not possible. Let's look at number 13. This time we have to draw a triangle, that's our goal, and then answer the problem. Label the vertices A, B, and C. So you're more than welcome to choose whatever figure you like, whatever orientation, but just make sure it goes A, B, C like that. You can make it obtuse if you want. It really doesn't matter. It's asking us the side included between the embedded side between angle A and angle C. Angle A is here, angle C is here. What's in between? It's not gonna be the segment AB or BC. We want the one that's closer to each other, and in that case, it's this side. So our answer is a segment AC. That's it, guys. I will see you next time.